Hello, welcome to the 4.4 notes for Math 2, solving quadratic equations using square roots. So first thing first, my first step here is going to be to isolate the squared term. We're going to do that by using what we know about solving equations. Okay. Now it says right here, use SAD-MEP to isolate the squared term. So just to remember, this is when I'm solving, I'm using order of operations backwards. Right, order of operations is PEMDAS. This is SAD-MEP, order of operations backwards. Then step 2 is to take the square root of both sides, and step 3 is to simplify. We've been dealing with square roots lately, but this is the first time that we're going to deal with them in an equation format. When we did 4.3 previously, we were dealing with expression. So know that a lot of the things that we did are going to contribute to this discussion, but we are going to have some new things to consider. Of special note, so squaring and square rooting are inverse operations. And what's meant by that is just like addition and subtraction are inverse operations, or multiplication and division are inverse operations. Squaring and square rooting are the inverse operations. Example 1, use the square root property to solve the equation. So I have the equation x squared equals 49. Now we're going to start off with like one step, we're going to move to 2 step, we're going to move to 3 steps, okay? We're going to build on this idea. So first thing first, x squared equals 49. My first step up here is to isolate the squared term. All right, so what is the squared term? X is what is squared, that's what I want to isolate. Isolate means get by itself. Oh, well, it is isolated. There's nothing else on that side of the equation that's in the way. Okay, so this first step's already done. Next step is to take the square root of both sides. So I'm going to take the square root of the left side and the square root of the right side. When I take the square root of x squared, I get x. Right? Square root and squaring, they undo each other. They're inverse operations. Is equal to the square root of 49. Now, what this is asking is it's asking what squared is 49, right? X squared, what squared is 49? Well, I know that 7 squared is 49. I also know that negative 7 quantity squared is 49 because a negative times a negative is a positive. So this number in here, this could be either negative 7 or positive 7. So we can write this in different ways. I can write x is equal to negative 7, comma 7. Or I can write this as x is equal to plus or minus 7. It depends on what platform you're using. So for example, if you were doing this on the online homework, there is a plus or minus button, right? So if you go to the keyboard, you can type in the plus or minus 7 button. If you were doing this using like the keyboard on your computer, there isn't a plus and minus button, so you would write them both out. Okay, but just know that they're the same thing. You have to have 2 answers. If you only include one answer, if you were to tell me only x is equal to 7, that's only half the answer. It's incomplete. Okay, B. Try this one. 48 is equal to x squared. Step 1, isolate the squared term. There's the squared term. It's already isolated, which means it's on one side of the equation by itself. So I take the square root of both sides because I need to find x. So to get rid of the squared, I take the square root. What is the square root of 49? I'm sorry. 49 was A. What is the square root of 48? Well, it's not a perfect square. So if I don't know that, I'm going to come over here and do the factor tree, just like we practiced in 4.3. So you can pick any two numbers that multiply to 48 other than 1 and 48. I'm going to go for 4 and 12. All right, 4 is not prime. I can multiply 2 by 2 to get that. Those are prime. What can I multiply to get 12? I'm going to go for 2 and 6 this time. 6 can be broken down into 3 times 2. So when I rewrite this, I have 2 times 2 times 2 times 2 times 3. Because I have an equation and I'm taking the square root of both sides, I must include plus or minus. It is vital and absolutely necessary. There's my arrow. Don't forget the plus and minus. Okay. So then, when I am taking square roots of things, I am looking for perfect squares. The square root of 2 times 2 is the same thing as the square root of 4, so I can bring out a 2. I have the square root of 2 times 2, which is the square root of 4, and I can bring out another 2. The plus or minus goes right in front of the whole numbers, and then I've got the square root of 3. That's what's left over, right? Multiply what's on the outside. This is positive or negative 2 times 2, which is 4, radical 3. Or this can be written as x equal to negative 4 radical 3 and positive 4 radical 3. If, let's say, like over here in green, you were to accidentally just say 4 radical 3 without the plus or minus, this is only half credit because it's only half right. We've only got one of the answers. Okay. So a note down here, answers can be written 2 different ways. You can either write plus or minus the number, or you could write minus the number, comma, and then the positive value. All right, but you must have 2 answers 95% of the time. The only time you're not going to have 2 answers is if I'm taking the square root of 0, which is 0. All right, C, same directions. Step 1, isolate the squared term. So this is x squared. The square is only acting on the x. Isolating it means I have to get rid of the negative 3. Well, that's negative 3 times x squared. So how do I move the negative 3? Because it's multiplied by the x squared, I need to divide by it. Make sure you divide and don't add. Then I'm left with x squared is equal to negative 8. To get x by itself, I take the square root of both sides. Now, I'm going to have a sidebar for a moment, so follow me over to the right hand of the screen over here. If I am asking for x squared is equal to negative 100, now I know my answer over here is negative 8, but for argument purposes, we're going to come over here and talk about negative 100. What squared gives me negative 100? Well, 10 squared gives me positive 100. And negative squared gives me positive 100. So how can I get negative 100? The answer is you can't with real numbers. So yes, I can find the value of the square root of a negative number. It's called imaginary numbers, and we're actually going to get into it in the next topic. But this is not part of our known number set at this point in time, so you can't, okay? So for right here, my answer is going to be no real solution. Please make sure that you've got no real solution, because there is a solution, it's just imaginary. Okay. So to make a note here, right down there in purple, I've got a negative radicand, okay, yields no real solution. Okay. The square root of a negative number is an imaginary solution. Yes, there's such a thing called imaginary numbers. If you've never heard that before, you're like, what? And we're not going to talk about those until we get to topic 5. Remember, a negative radicand, that means a number underneath the radical is negative. That gives me an imaginary solution. So your answer is going to be no real solution. That only works after you've isolated the squared term. So for example, in problem D, you're like, oh, I have something x squared is equal to negative 450. No, before you can say like that D is no real solution, you have to isolate x squared first. Then you can possibly tell me if there's no real solution. So D, negative 450 is equal to negative 5x squared. How do I move the negative 5? This is negative 5x squared. What's the operation between the negative 5 and the x squared? It's multiplication. So to move it, I need to divide. So this leaves me with x squared is equal to negative 450 divided by negative 5 is positive 90. So I take the square root of both sides. X is equal to plus or minus, and I need to do the factor tree for 90. There's a lot of different ways you can divide 90. I'm going to go for 3 and 30. 30 can be broken down into 3 and 10. 10 can be broken down into 2 and 5. So when I write these numbers underneath my radical, make sure you have plus or minus the square root of 3 times 3 times 2 times 5. And we learned in 4.3 that I'm looking for pairs, right? I'm looking for perfect squares. So square root of 3 times 3 is the square root of 9, which we know is 3. So I take that out. Left-hand side, I have 2 times 5, so I'm going to multiply that back together. So I get x is equal to positive or negative 3 radical 10. Or you could write this as x is equal to negative 3 radical 10 and positive 3 radical 10. I usually tend to write it out twice. I know that this works on every keyboard, so it just works well for me. In your Savas assignment, you will be able to do plus or minus, but if you forget the plus or minus symbol, it won't be fully correct. Okay, so E, F, G, and H, we get into, well, I guess E is actually very similar to C and D. So what I would like you to do is I would like you to pause this video right here, and I would like you to work out 7x squared equals 112 and solve for the values of x before you watch my solution. So this is an opportunity for your turn, right? This is a you do it. Try E for us. Okay, so hopefully you've already solved E. And if you did it right, then you would get -4 and +4 for your answer. Yay, hopefully it went well. Okay, so for 7x squared equals 112, I got to get rid of the 7. So I divide everything by 7. And that leaves me with x squared is equal to 16. Got to get x by itself. So to undo the squaring, I take the square root of both sides. Whatever you do to one side, you have to do to the other side. The square root of x squared gives me x, and I get plus or minus the square root of 16. Well, what is the square root of 16? If you know that it's 4, awesome. If you're like, I don't know my perfect squares very well, then you could do the factor tree. Okay, pair of 2's, bring one out. Pair of 2's, bring one out. And x equal to plus or minus 4. Or x equal to -4 and +4. Either one. Okay? All right. Hopefully you're feeling good about that. Now, problem F. X squared minus 5 equals 22. First step, still isolate the squared term. X squared minus 5 equals 22. So pause and think about it. What do I need to do to get x squared by itself? The minus 5 is in the way, so how do I move it? Well, the operation here is that I'm subtracting 5. So the inverse operation is going to be to add 5. So I get x squared equals 27. How do I get x by itself? I take the square root. That's the inverse operation of squaring something. Whatever I do to one side of the equation, I have to do to the other. So now I need to take the square root of 27. All right, looking for numbers that multiply to 27, like 3 and 9. All right, and 9 breaks down to 3 times 3. So I get x is equal to plus or minus the square root of 3 times 3 times 3. One pair of 3's, I can bring that out, and I leave 1 3 inside. So x is equal to -3 radical 3 and +3 radical 3. All right, G and H, now I've got more layers here. So I've got additional steps to do before I can isolate the squared term. So I'm moving my steps along with me here. All right. So g of x, I have 3x squared plus 17 equals 209. Let's talk about these order of operations. So we know that when I'm solving, I have to do order of operations in reverse order. So to isolate the squared term, x squared is my squared term, right? The squared only acts on the x. Then I need to look at adding and subtracting something first if I can. So I have 3x squared plus 17 equals 209. Oh, well, I'm adding the 17. That means to move it, I'm going to subtract it. So I'm going to have to move the 17 first. I'm left with 3x squared is equal to 192. Now, you don't get a choice. You can't move the 3. You have to move the 17 first. Okay, you've got to follow your order of operations. Next, if I order of operations is going to be if I can multiply or divide something. So I'm looking for multiplication or division. Well, I have 3 times x squared equals 192. So here I can undo the multiplication by dividing. Leaves me with x squared is equal to 64. Next, I undo the exponent if possible. Oh, I do have an exponent, x squared. What's the inverse operation of squaring something? Square root. And when I take the square root of both sides, I end up with plus or minus. Now, if you don't know what the square root of 64 is, you could do your factor tree. Otherwise, hopefully you're familiar with a lot of these perfect squares for smaller numbers, and this is just going to be 8, because 8 squared is 64. So I could write this as x equal to plus or minus 8, or negative 8 and positive 8, either one of these. Hopefully that seems reasonable, right? We're combining all these different skills that we've learned throughout the years of math. And I invite you here to pause for problem H and go ahead and try to do H on your own, right? So this is another, your turn. Okay, so if you've tried H, let's go ahead and work it out together. The answer should be plus or minus 5 radical 2. Okay, so if you're celebrating right now, good job. If not, maybe you got close. So let's see how close you got. The first thing I need to do, again, is add or subtract. So go back through here. So I'm always going to look to add or subtract first when I am solving. Trying to get x squared by itself. So I have minus 10. I'm going to add 10. Negative 6x squared equals negative 310 plus 10 gives me negative 300. All right, there's nothing else I can add or subtract, so I look to multiply and divide. I have negative 6 times x squared. This is multiplication. So to move it, I'm going to divide. When I divide, that leaves me with x squared is equal to negative 300 divided by negative 6 is 50. Now I've isolated my squared term. Be cautious, especially on these problems that have a lot of negatives. It would be easy to make an error and try to say, oh, no real solution early on because I've got some negatives here. But you can't make that determination until you get to this point where I've got something squared equals a number, okay? So only then, if the number is negative, then it's no real solution. But since it's positive, I can keep going. So take square root. Square root of x squared is x. Oh, 50 is not a perfect square. All right, do my factor tree. And for 50, you could break it down to 2 and 25 or 5 and 10, and then keep going. So I get 2 times 5 times 5. A pair of 5, so I bring a 5 out, and I leave the 2 inside. Plus or minus 5 radical 2, which is the same as negative 5 radical 2 and positive 5 radical 2. All right. Math starts getting way cooler when I start talking about how, like putting it in context, right? What I could do with this in real life. So example 2 is just that. It's a word problem for you. I'm going to go ahead and I'm going to scroll down. And I'm going to come up with a little drawing for us here. So the base of a 10-foot ladder is 4 feet from a building. I need a building. All right. I don't know why I can't get that to go straight down, but let's pretend like it does. And then I've got a ladder. It's a very curvy ladder. Give me a break. Sorry. All right. And the ladder is 10 feet long. It says that the base of the ladder is 4 feet from the building. If the ladder reaches the flat roof, how tall is the building? So I want to know how tall this is. Now we're going to assume that all buildings are perpendicular to the ground, okay? Which 99 point something percent of them are, right? And this question asks for 2 things. It asks for the height of the building as an exact answer and rounded to the nearest tenth. All right, well, bringing it back to what we talked about last week, the Pythagorean theorem. All right, we had a little review in 4.3 that the Pythagorean theorem is a theorem that talks about the sum of the length of the sides, the sum of the squared lengths of the sides is equal to the squared length of the hypotenuse for a right triangle, which is what we have here. We have a right triangle with 2 legs and a hypotenuse. It doesn't matter which leg is A and which leg is B. It does matter that C is the hypotenuse. So C needs to be this side across from the right angle. All right, so I'm going to start plugging this in. A squared, so I'm going to call that 4. B squared is my variable. It's what I'm looking for. Equals C squared, which is 10 squared. All right, and I start solving. 4 squared is 16. 10 squared is 100. And you get a problem that's kind of the same format as example F above. So I need to isolate x squared. Do that by subtracting 16 from both sides. And then to get x by itself, I take the square root. Now when I take the square root of both sides here, I know I always get plus or minus. All right. We take the square root of 64. Let's see, I'm going to use 4 and 21. 4 breaks down to 2 times 2, and 21 breaks down to 3 times 7. So I have 2 times 2 times 3 times 7. All right. I've got a pair of 2's. So 1 comes out, right? Square root of 4 is 2. And the 3 times 7 I multiply back together inside. Now this means that x is equal to negative 2 radical 21 and positive 2 radical 21. Well, 2 radical 21 is just a number. When I take this and I put it in context, so when I look at it through the lens of this being a real life problem, can I have a negative height of a building? No. Okay. So in this case, because I'm talking about height and I'm making a real applicable problem, I have a new condition. Okay. And this condition only allows for positive values. So the exact answer is going to be 2 radical 21, and then my units will be feet. That's exact. It says use radicals as needed. It's not, I haven't rounded anything. B asks for the height of the building approximately, round to the nearest tenth as needed. So now what you're going to do is you're going to get out your handy dandy calculator, or you're going to use Desmos, and I'm going to pull the Desmos screen over right now. Okay. And yes, this is a graphing calculator, but I can also just use this window right here as a calculator. So when I want to type 2 radical 21, okay, I can do that in a couple different ways. I can do 2, and then okay. So I have 2, and then I need the square root of 21. So you can either click down here and get this keyboard. Square root is going to be down here in the bottom. So square root of 21. You don't even have to hit enter. It's just going to give you the value. Okay, so that's one way to do it. The other way to do it is to type square root how we were doing in our chat. So SQRT will automatically give me the square root. So let's do that again. So what I did, I typed SQRT, and it gives me the square root. So either way, I can get that answer. So I get 9.165. .165, and then it keeps going, right? This problem says round to the nearest tenth. Ooh, rounding skills. Here we go. 9 point something, right? So I have 9.1, and I look at the next number. The next number is 6. Since 6 is 5 or higher, then I round up, and this becomes 9.2 feet. And so these are going to be my answers. I like this one because it gives more context to 2 radical 21 is a real number. It's approximately 9.2. So be aware of that. I think you have 1 or 2 of these assignments in your, or problems like this in your assignment. Okay. Thank you very much for engaging today, guys. I hope this makes good sense to you. Take care. Bye-bye.